So we have a problem to evaluate limit of natural logarithm of x plus 1 divided by x as x tends to 0. So let us first check the format of this kind of problem. If I put in at x is equal to 0, we will have ln, I will have ln of 1, and ln of 1 is equal to 0, or natural logarithm of 1 is equal to 0, but also x is equal to 0. So we end up with the format of 0 out of 0, which is an indeterminate form. So from there, that means we need to apply the Hospitalis rule. So what does it say? If we are limiting a function f of x out of g of x as x tends to 0, this is the same as limiting the function as x tends to 0 of, if we take the first derivative of the function divided by the first derivative of this function. So what we do, we look for f of x prime. F of x, we are taking it to be the ln or the natural logarithm of 1 plus x. So we are saying we are differentiating with respect to x of ln or natural logarithm of x plus 1. And what is that going to be? This is going to be differentiating this x, okay, divided by the original. So you differentiate this divided by x plus 1. So this gives you 1 plus 1 divided by 1 plus x. Then what is g of x? G of x is equal to, this is the first derivative of g of x, is the same as differentiating that x, and this gives us 1. So what does that call us to do? So this Hospitalis rule enables us to do what? To finish this. So limit as x tends to 0 of natural logarithm of x plus 1 divided by x. This will be the same as taking limit as x tends to 0 of 1 out of x plus 1 divided by the derivative of x is equal to 1. So divided by 1. So that means I'll be taking, is the same as taking the limit of x is equal to 0 of 1 out of x plus 1. And what is that going to be? So put in x is equal to 0, this will be 0 plus 1, and that is 1. So the function, the limit, therefore, limit as x tends to 0 of natural logarithm of x plus 1 divided by x is equal to 1. We are taking another example of tan. So we have limit as x tends to 0 of tan of x minus x divided by what? So divided by x minus sine x. So we also check if it is indeterminate. So we know tan of x, tan of 0 is 0. So as x is x, so if we put in 0, it becomes 0. Sine of 0 is 0. So we'll find that sine of 0 is also 0. So we'll end up with a form. We'll end up with a form of 0 out of 0. So which is also indeterminate. This is an indeterminate form of the format 0 out of 0. So we use L'Hopital's. So L'Hopital's rule says limit as x tends to 0 of that function. Okay. Let me say f of x divided by g of x is the same as limit as x tends to 0 of f prime of x divided by g prime of x. So we need to look for the derivative of tan x minus x. So this is the same as sec squared x minus 1. The derivative of a tan is sec squared x. Then what is the derivative of x minus sine x? This is the same as 1 minus cos x. So meaning this is going to be limit as x tends to 0 of sec squared x minus 1 divided by 1 minus cos x. So if we put in 0, this would be 1 out of cos squared. So 1 out of cos 0 is 1. So this becomes 1 minus 1, and that becomes 0. What about 1 minus 1? That becomes 0. So we again go ahead. So we need to find the derivative of this. So what is the derivative? If we have a sec squared x, what is the derivative of this function? So is this the same as, we are saying we need to take a second derivative here. So differentiating the x of sec squared x minus 1, the same as differentiating tan squared x. And we have said that this is the same as 2 tan x sec squared x. What about differentiating d by the x of 1 minus cos x? This is the same as positive sine of x. So this will be the same as limit as x tends to 0 of what? Of 2 tan x sec squared x out of cos x. So take limit, put in zeros, so this becomes 0 out of 1. So this is 0. So this becomes tan of 0, which is 0 times 2, 0 times sec squared. So the whole thing will go. Then divided by cos 0, which is equal to 1. And that's all.